Good morning, everybody. Today's lecture will be based on heat transfer calculation. Whenever you want to get separated fluid, oil or gas quickly, so sometimes you add heat also. So how much heat you need to separate? So that sort of calculation we'll try to do in this lecture. So we have seen oil and gas wellbore typically produces oil, gas, water and sand. Okay. Now because of gravity or weight of the liquid is higher than gas, so liquid will be forming a lower layer and gas will be going out. When you reduce pressure in different stages of separator, gas will be coming out more and more. Okay. So let's say one separator I have, inject one wellbore fluid, it is coming from wellhead, I am writing WH. So wellhead, then there will be a choke, then there will be maybe some other manifold, then it will come to separator, then you are creating gas layer, oil layer, water layer. Okay. Now oil particle, water particle is here. Okay. Okay, water particle, these are water. Now or oil particle is there in water. Okay. If you want to separate, so there are several mechanisms we have discussed already. Electrostatic coalescers are there, mechanical coalescing systems are there. You have chemical mechanism to change fluid surfactant property, and you can get bigger particle size because you have seen this Vt, terminal velocity, is proportional to dm square or particle or droplet diameter square, and inverse proportional to viscosity. Viscosity increasing, terminal velocity will be reducing. Okay. And depends on del Sg, specific gravity. So specific gravity is very high, your terminal velocity also will be very high, the difference of specific velocity. Okay. So you need high terminal velocity so that quickly particle will get settled. So dm, if you are increasing, it will settle quickly. If you can change viscosity, your particle will be settling quickly. So using heat, actually you are changing viscosity. Okay. So temperature you are changing. Okay. When temperature changing, viscosity changing. Now in oil and gas separator systems, there will be one heater or heating element will be here somewhere. Okay. It is like this. If you see this symbols, it will be like this. So heating element will be there. So you have one fire tube, so you get hot gas. So hot gas will be passing through this hot gas. Okay. So hot gas when passing through the pipe and fluid surrounding all around the pipe, so the fluid will get heated. Okay. When it is getting heated, your viscosity property will change. Okay. And this is okay. So fire tube, water tube. So sometime in boiler, when you are heating water, boiler you are using it for thermal power plants, NTPC or all this thermal power or coal based power plants, they uses boiler. Okay. They will be using boiler, and the boiler will be producing lots of steam. So that steam is used for power generation, but in this case you are not using for power generation, rather you are using for heating your fluid inside separator. Okay. And hot gas is passing through the pipe, that's why it is called fire tube boiler. So fire tube. So hot gas passing through tube. Okay. That's why fire tube. When hot steam is going through the pipe and outside flue gas or hot gas is there, for example, you have one pipe passing lots of steam or water, and outside burner is there. Okay. So hot gas outside pipe, so that will be actually water tube boiler. Water tube boiler. So in your case you are using actually fire tube, okay, not water tube. So you should know the difference. Now when you are heating, how much heat will be required? There are some formula, just we will try to solve some problem. The heat input requirement, heat heat input equation. So, required heat input in an insulated vessel, in an insulated vessel. Okay. Insulated means like you are not allowing heat to go out. Insulation you are using for electrical conductor system also, but here in heat transfer system, insulation means you are not allowing heat to go out. Okay. So, whatever heat you are giving, that heat will be used for heating your fluid only. Insulated vessel theoretical heat will be W dot S dot del T. Okay. So, W dot is your specific weight of fluid or mass of fluid. Instead of weight we can write mass of fluid going through the pipe, or okay, or let us say fire tube is there, you are drawing like this, right, fire tube, sorry, you have drawn fire tube like this, right. So, the mass passing through this fire tube is W, and S is specific heat, and mass of fluid unit will be pound per hour. Specific heat unit will be BTU, British thermal unit, pound degree Fahrenheit, and it will be 0.5 for oil and 1 for water. Okay. And del T is a temperature increase. So, temperature increasing 80 to 100 degrees centigrade. So, temperature difference will be like 20 degree. So, the temperature increase, it will be, it is not unitless. So, it should have units, so degree Fahrenheit. So, now QTH equals 350 by 24, you are converting unit. So, this factor coming QO SGO, QO means oil, SGO again is specific gravity, SG specific gravity, okay, specific gravity volume into a specific gravity, 0.5 ST into del T. Okay. So, W you are writing as a, okay, so W actually you are writing QO SGO, okay, and S value already 0.5 and unit conversion 350 by 24. Now, this is for oil. Now, same pipe will have oil and water mixture actually, some vessel. So, yeah, so this mass actually, this is mass you are heating. So, whatever oil or gas you are taking inside separator, so that mass you are calculating here. Okay. So, 350 divided by 24, now Q oil, Q water, SG water 0.5 del T. Okay. Now, if you all summarize all this part, then it will come in like this: 14.6 del T, 0.5 QO SGO plus QW SGW, specific gravity oil, specific gravity water. Okay. Heat loss, here water is 1, so 0.5 the term is not coming. Okay. Heat loss 10% we are assuming. Okay. So, input heat equals Q theoretical 0.9. So, 90% you are using. So, it will be like 16.2 del T QO SGO divided by 0.5 or by 2 I can write, plus QW and SGW. Okay. QW means water flow rate, SGW oil flow rate. So, this is the formula for calculating how much amount of heat required for certain amount of oil and gas passing through the separator. So, what happens, separator is there. So, continuously oil and gas will be entering, oil, gas and mixture of fluid will be entering and continuously will be going out. So, how much heat will be required? So, that this calculation will give that much of heat, that the input heat is there, that you have to calculate. Okay. Now, see a problem. A heater treater has a heater treater increases, not has, heater treater increases, I created this problem, so there is some mistake. Okay. A heater treater increases temperature of oil with less than 10% and it is insulated again, insulated system. Water from 80 degree to water, not water, we can write oil and gas, oil plus water. Temperature increasing 80 degree Fahrenheit to 100 degree Fahrenheit. Water specific gravity 1, oil flow rate 5000 psi, inlet temperature 80 degree Fahrenheit, treating temperature 120 degree Fahrenheit, oil specific gravity 0.875, water specific gravity equals 1 and it is insulated. Okay, water specific already given. Okay, no need this one then. Then you have to calculate amount of heat required in million British thermal unit per hour. So, how to do it? So, Q heat, Q formula you remember 16.2, 100 minus 80, 4500, why 4500? Because 90% okay, less than, okay. So, here I was assuming that water cut is 10%. Okay. So, oil content is 90%. So, oil this is oil plus water flow rate 5000 BPD. So, actually because of 10% water cut implies 5000 into 0.1 is 500 BPD water is there. Okay. And remaining 90% means 5000 into 0.9 equals 4500 BPD oil. Okay. Here I am writing BPD, small b, again I am repeating BPD, or I can write BOPD, or I can write BWPD or B per D. Okay. So, I can there is no standard rule. So, many books will be writing BOPD, BWPD means barrel of water per day, BOPD means barrel of oil per day, B/D means barrel per day. Sometimes we say blue barrel. Okay. Blue barrel is initially that 100 years back people are using blue colored drum barrel. So, that is why they write the name blue barrel. Okay. So, if you write in small letter, capital letter, or B per day, BOPD or BPD, everything okay, because there is no standard rule for that. Okay. So, I will write formula for Q. Q equals 16.2 and temperature difference. Temperature difference means T final minus T initial, okay, or del T. This is actually del T. Okay. And then QO into QO into your specific gravity into your heat capacity C plus Q water, this is oil, Q water, C water, SG water. Okay. Heater treater increases temperature of oil with less than 10% water. With less than, I will not write this one. temperature oil and water. Heater treater increases temperature of oil and water 80 degree Fahrenheit to 100 degree Fahrenheit. Okay, this is better. This is not good. Okay. So now we will put the values 16.2 and temperature difference increase 80 to 120 degree Fahrenheit. That means this is 40. 80 to make it 100 is easier. Okay. So it is 80 to 100, so it's 20, and QO is given 4500 into SGO given 0.875. C value actually it is not given, so assume C value. C oil equals 0.5, C water equals 1. Again BTU per unit you have to check actually. BTU per LB per degree Fahrenheit. Okay. So this is 0.5 plus Q water 500 into C water is 1 and SG water specific gravity 1. Okay. Now if we calculate all this parameter 324 into 2468.75, finally it will come 799875 or almost 0.8 MMBTU per hour. Okay, so this is your final calculation. So similar question I can give in your exam, so I can change data. So actually initially created some problems, so when I was solving I changed the data. So you have to use the changed formula and you have to check this calculation if things are okay. Similar problem I can give in your exam also or in assignment also. So thank you very much. We will start next lecture with two-phase separator.